From Microbe TV, this is TWiP, This Week in Parasitism, episode 180, recorded on February 7th, 2020. I'm Vincent Racaniello, and joining me here today in New York City, Dickson Despommier.
Good evening, Vincent.
And remotely, Daniel Griffin.
Hello, everybody.
And Daniel.
It's late on a Friday, 5:30, unusually late.
Yeah.
It's dark and cold outside.
It's okay. It's all right.
It's very windy. Is it windy out there on Long Island?
It is incredibly windy, but since it's after 5, I know we don't have video, but you can't see me enjoying my Friday evening coronavirus beer. With my, I've got some Lyme disease on the side.
Wonderful. Corona with Lyme.
Like it.
You really have a Corona?
I do, and I'm going to have some gummy ascaris worms afterwards.
All right.
To wash it all down.
There you go.
Ascaris, that was
Sounds good.
That was our case last time.
Indeed.
It was.
All right, speaking of cases, let's dive right in.
Hey.
Okay, let's do that. So let's start with case from TWiP 179. We were in eastern Uganda. We were up in the mountains. It was right by the Kenya border. It was the rainy season. And this 6-year-old girl was brought in by her mother, initially brought to the clinic on Monday, reporting several days of feeling poorly, headache, fever, muscle aches. They did a negative malaria smear on Monday. And on Wednesday, she returns and sees me. And at this point, she's feeling worse. She was told, if you feel worse, come back. She is feeling worse, comes back, brought back by mom. The fevers are higher. The headache is worse. On exam, the lungs were clear, but she did have tenderness in the left side of her belly with a palpable enlarged spleen. We spoke a little bit about the context here, right? So we're up in the mountains, a lot of mosquitoes, rainy season. She's living in fairly good conditions. She's a well-dressed young gal, but her home is dirt floor but concrete walls. The toilet is really just, you go out back and there's a bunch of branches and such covering a big dugout hole. So it's a drop toilet, I guess you could call that. And I think the drop is what you're worried is going to happen when you climb out of these branches and covering. At least that's how I felt when I went to some of these.
Oh, you're right.
And same dietary habits as we've described for a lot of people in this area of Uganda. So a lot of rice, a lot of starch-based, high carbs, basically. Yeah. This little girl's living in a home with no mosquito netting. Water is being collected from this local stream. She doesn't have any siblings, which, you'd say is kind of unique for a 6-year-old. Most kids this age would have a sibling or 2 or 3 by now. And she is HIV negative.
Right.
Okay. Sophia writes, hello, professors. This will be short as I'm writing this in a rush, I would say. If it's not malaria, first smear negative. But how about a second one? Then it's leishmania. Or I could be wrong. Incidentally, question for Dr. Griffin. Speaking of limited resource settings, when are RDTs for malaria used instead of the smears, and how reliable are they? Do you do them at all? Apparently, there's a mutation in the population in some countries which renders these tests quite unreliable. Just wondering. Here's to another year of podcasting and more cases. All the best to you, and thank you for doing this. Sophia, Greece, 0 degrees C.
Burr.
Okay.
Burr.
Let me jump in on that. This is, we're not saying what it is yet. We're leaving this a mystery still. But yeah, one of the tests that was done was an investigation looking for malaria, and the 2 different options were brought up. 2 main options, looking under the microscope, so doing a blood smear, going ahead and going through the staining process and looking under a microscope. That's one option. The other are these RDTs, or rapid detection tests for malaria. And, part of the decision might be cost-based, and it's going to vary in different areas. In some areas, you can do a microscopy test for as little as, we'll say, 32 cents US. But it might cost you more, and might cost you more might have to do with the fact that you need trained people to do this. And in some settings, salary, et cetera. Mm-hmm. An RDT is much more, I'll say, user-friendly. The cheapest you can get these for is going to be about twice that, so about 60 cents, but usually more in the range of about $1 US. So you might be making a decision there. The other thing, I guess, about the RDT, I'll say, is it doesn't give you the severity, where with microscopy, you get to look and say, oh, we've got about 1%, we've got 10%. Right. Some of the RDTs, I will tell you, can speciate. So an RDT can sometimes tell you falciparum versus Vivax ovale, etc. Microscopy, again, a trained microscopist can tell you the difference. Someone not as trained wouldn't necessarily be able to tell you the difference.
Right.
Dickson, are you a trained microscopist?
I am.
Good. Can you take the next one?
Sure. Peter writes, Dear doctors, having thought about this case study, I believe that a reasonable guess that appears to fit the geographic location and patient symptoms is schistosomiasis, a parasitic disease caused by trematode worms of the genus Schistosoma. This case appears to be a recent acute infection since symptoms only began a few days ago. The diagnosis is supported by the facts that the girl's recent poor health, particularly her enlarged and sensitive spleen, chronic infection, also caused liver inflammation. The family gets their water from a stream that presumably is the habitat for the parasite's intermediate snail host, which, that in mind, the girl's parents and their neighbors should also be tested for schistosomiasis. Given the location, the most likely species is Schistosoma mansoni. Praziquantel is the recommended treatment against all forms of schistosomiasis. The Praziquantel Consortium has developed a formulation that is more suitable for young children. See links below. According to Parasitic Diseases 7th edition, a short course of steroid medication prior to the use of Praziquantel can help prevent adverse effects of antihelminthic treatment for acute infection. Some useful links, and he lists 1, 2, 3, 4. Regards, Peter.
Okay, Daniel.
All right. Mandy writes, hello, Dickson, Vincent, and Daniel from Nashville, Tennessee. I hope this email finds you all well and settling into the new year. I have a short story to share before I give my case guess that I hope Dickson will enjoy as much as he enjoyed the tale of the squirrel and the botfly. Each month, my 10-year-old son has a book report due at school, and the teacher gives them a genre, and the students are allowed to pick their own subject from there. This month, they have been assigned biography. I was pitching different subjects to him in the truck on the way home to school to help him narrow his search, and I asked him if he would want to study someone from science, and began to rattle off some of the well-known scientists that would make good subjects for a fourth grade book report. After several suggestions of mine that he rejected, my daughter spoke up and said, what about that parasite guy? I should note that I have often finished an episode of TWiP with my kids in the car, and my 7, soon-to-be 8-year-old daughter is fascinated by TWiP and often asks me to show her photos of the parasites that have been discussed.
Good for her.
I naturally thought any of the TWiP hosts would make excellent book report subjects. Information does not solely have to come from a book, but is presented in a report format. But I asked her which one. She said, I'm ready for this. Dickson, he talks a lot and knows everything. I chuckled at her summary and asked my son, who seemed to think about it and then decided to keep looking.
Right.
I hope Dickson isn't too disappointed not to win the coveted book report position. It's really an honor just to be nominated.
I know. I dig it. I do.
All right. On to the case. There was not a surplus of diagnostic information in this case, so I tried to break it down for analysis. When Daniel first began the presentation, I immediately thought of malaria. Then Daniel chipped away at that idea by telling us that the blood smear was negative, and again reminded us of this negative smear during Dickson and Vincent's follow-up questions. The girl was told to return in 2 days if she felt worse. Being a mom, it struck me as odd that she was only instructed to wait 2 days. Typically, when I take my kids to the doctor, they come back if time is closer to 4 or 5 days. After reviewing some malaria literature, I came to the conclusion that the physicians were using the 2-day time limit as a diagnostic tool in search of tertian fever. Coupling that with the fact that one negative blood smear does not rule out malaria, I believe this girl has malaria caused by Plasmodium falciparum. Living in the mountains and not utilizing mosquito nets is a gamble, and hopefully swift treatment resolved her illness. Congratulations on your nomination, Dickson. Thank you all again for all that you do. Keep on twipping.
Mandy, I'm honored. No, I really mean that sincerely.
Interesting diagnosis.
Interesting diagnosis.
James writes, hey, TWiPs, not twerps.
Oof.
So, in summary, 6-year-old girl with vague system complaints, splenomegaly fever, East Uganda mountains. What would I ask my medical students to do? Create a differential. 1, neoplasm. 2, sickle cell or other hemoglobinopathy, bone pain. 3, autoimmune, young. 4, metabolic disease, Gaucher, etc., but I would not expect fever, constitutional symptoms. 5, infection. A, fungus. Only Histoplasma duboisi comes to mind, probably wrong part of the continent, though. Virus, the various torch, EBV agents, HIV. Bacterial, seen with endocarditis sometimes, typhoid, some others. D, parasites. Parasites causing splenomegaly is actually not that short a list. It is TWiP after all. Toxoplasma, the T of torch, can do it. Malaria can do it. And one negative smear really doesn't exclude it. Is this the horse and not the zebra on my list? Schistosomiasis can do it probably via portal hypotension. 6 seems awfully young for that, but it's on the list. Leishmania, again, so soon after we already did. Kayla Azar clearly can do this. African trypanosomiasis is on the list. Maybe a fluke like Clonorchis and fasciola. Could be. I think the pathogenesis might be similar to schistosoma, though, and she's a little one. Echinococcus, possible. E. histolytica in liver blocking blood flow. Starting to reach here. Asker is going up biliary ducts, another reach. So, what do we do in a resource-poor environment? What would I do if on one of my mission trips to Nicaragua, stool O&P times 3 blood smear evaluation, a really OCD one like I did on returning missionaries when practicing pathology, not just a quick scan. Is ultrasound available? Often is, even out in the sticks, and might help with some of the causes, especially if Doppler for blood flow included. Bone marrow aspirate with a direct smear, possible if you have a good pathologist available. I certainly doubt any molecular tests available, maybe some serologies. Refer to a bigger city. Expensive in those countries. Wish I had a single diagnosis to propose, but a diagnosis list seems like the best I can do. Differential diagnosis. Okay, from Rocky Vista University. There you go. Dickson.
Jim writes, greetings, intrepid aces of the anti-malarial squadron. This still looks like a case of malaria based on the symptoms presented despite the negative blood smear. I did consider some other endemic parasites with similar symptoms, but none of them seemed quite right. If this is indeed malaria, then there can be no doubt as to how she got it. The only delivery system is the infamous and truly awful Anopheles mosquito. Make no mistake about it. When these little vampires need a blood meal, they don't care who they have to get down to get it. It's early evening at the end of a rainy season, and the mosquito squadron is vectoring in to deliver its parasitic payload. Alas, at the very same time these mosquitoes are decanting parasites, they are picking them up from infected hosts. For some unlucky humans, this process will prove to be fatal. Fortunately for today's patient, she is in the right place at the right time, and there are effective antimalarial medications to help quell the infection. The combination of drugs to be used will depend on the type of malaria and the degree of infection. Unhappily, though, this may not be the first time in her life she has had malaria, and probably won't be the last. Not everyone seems to agree with my guess this time. Perhaps I missed a more obvious parasite in this case, but damn it, doctors, I'm only a Jim. TWiP rules, as always. Take care, Jim in Vancouver.
Nice.
Yeah.
Daniel.
Andrew writes, Kia ora from Pongaroa. Book not one yet. Is there a signed video version? My diagnosis for the East Ugandan 6-year-old girl feeling poorly with headache, fever, and muscle aches. My guess is that it's probably visceral leishmaniasis. For me, there were 3 parasites that came into question. Practicing a bit of Bayesian thinking, I came to the following possibilities. Priors. 1. Echinococcus granulosus. Hi, Dad. It's 10% probability. The parasite can cause cysts in the spleen, but the rate of development of the disease and the lack of animal protein in the diet, this is probably not a herding family, so dogs would not be in abundance, led me to give it a low chance. As an aside, New Zealanders have been declared provisionally free from hydatid since 2002. Yay! Strips of tarmac at the sides of rural roads still exist, and this is where working dogs were dosed to clear them of the parasite. Sheepdogs are still only allowed to eat cooked offal, and livestock carcasses must be quickly buried to stop foraging. Children were very vulnerable to the parasite, playing in areas where dogs had defecated. Schistosoma mansoni, 25% probability. The water source for the family is the river, so infection is possible via the snail vector through bathing, playing in the water, etc. But the lungs are clear, indicating the life cycle dependent migration through the lungs is probably not happening. So I'm keeping this as an alternate diagnosis. 3, Leishmaniasis donovani, 65%. The symptoms all fit, and especially the enlarged spleen. The lack of netting is also a factor, as the vectors are sandflies. Watching Parasitic Diseases Lecture Number 8, Visceral Leishmaniasis, on YouTube gave me the confidence up to the probability of this diagnosis to 80%, and to reduce the other to 5% and 15% respectively. The video recommends using a highly sensitive and specific RK39 antigen ELISA available in many endemic areas, and a bone marrow aspiration to confirm the diagnosis. The video indicates that pentavalent antimonials are preferred in Africa, but I will have to leave it to others to be more specific, as having misread parental as parental. I think I've learned enough new words for the day, and not being a doctor. Prevention is sleeping under insecticide impregnated bed nets and avoiding outdoor activities when the little beasts are biting. We know all about them in Pongaroa. It is amazing how brutal such a tiny insect can be. The weather here is summery 25°C, and a few clouds are scudding across a milky blue sky, which brings me to a pick that might interest some listeners. I use an app called Globe Observer to send ground-based pictures of clouds to meteorologists when satellites are passing overhead. It also has a map. It also has a project to map the habitats of mosquitoes, which is sponsored by NASA, which will be of use to researchers. The link is, and he puts a link in here.
Right.
And lastly, I have become a proud patron of the TWiPverse, of which I get all the podcasts. Na mihi, Andrew.
Thank you, Andrew, for your support. We appreciate it.
Yes, we do. Yes, we do.
Samantha writes, TWiP hosts, greetings from Miami, where it is an extraordinarily pleasant 70 outside. Lots of sun and low humidity. I've been a long-time lurker of the podcast and finally have decided to get in on the fun of guessing the cases. When I initially heard this case, falciparum, malaria, and EBV came to mind. Both have a high prevalence in sub-Saharan Africa and can cause fever, headache, and an enlarged spleen. I subsequently ruled out EBV because these manifestations of infection are uncommon in a child this young, usually reserved for adolescents and young adult. Also, seeing how this is TWiP and not TWiV, I decided to move on, of course, not before going down a wormhole of learning about malaria and EBV co-infections and the elevated risk for Burkitt's lymphoma, where P. falciparum prevalence is high. I am not impressed by the negative blood smear of this 6-year-old patient, seeing how the child has pertinent risk factors. It is rainy season. She sleeps without a bed net. I think that she should be retested. Depending on what the lab has available, LAMP assays and other nucleic acid tests may provide a higher sensitivity than a blood smear. According to Parasitic Diseases, 7th edition, fever, myalgia, headache, and abdominal discomfort are common symptoms of malaria, albeit in children they may be present with more nonspecific symptoms. Finally, I checked out the epidemiology of malaria in Uganda and found that in children with confirmed malaria, 92% were infected with P. falciparum alone, 0.4% with non-falciparum species, and the rest were falciparum co-infections. Another study found an association between submicroscopic parasitemia and children presenting with fevers in Uganda, indicating a possibility for clinical consequences of submicroscopic infections. For uncomplicated P. falciparum malaria, WHO recommendations are artemisinin combination therapies. For a complete list I'd like to discuss that leishmaniasis also ran through my mind for this child. Eastern Uganda is endemic for visceral leishmaniasis caused by L. donovani, and clinical features in these areas tend to include fever, weight loss, and an enlarged spleen, with the most affected group being males between 5 and 14 years of age. An RK29 rapid antigen test has been found to be highly sensitive and specific for patients in Uganda. Therefore, I would want to run a diagnostic test for this as well. And there it is. Even if I am not right, I enjoyed the process.
Cool.
Sam.
Nice.
Dickson.
Yes, sir. Kevin writes, Case 179, pediatric tropical splenomegaly. A 6-year-old girl with an enlarged spleen and an initial negative malaria smear. Once upon a time, the 1960s, department stores sold formaldehyde-preserved frogs. I used just such a leopard frog for my 6th grade 1968 science fair project. I dutifully discussed the frog's various internal organs, but skimmed over the spleen's function. My interlocutor asked what a spleen did, and countered my cursory reply by stating that the spleen is a mystery organ. Here we are in 2020, and though one may live without one, the spleen has many jobs: hematopoiesis, shouldering 25% of the body's lymphoid tissue, removal of senescent red blood cells, and as a kind of platelet warehouse. Forgive this spleen palaver. TWiP has a way of dredging up quasi-relevant memories. Please allow a few further splenic comments relative to children. According to the 2019 up-to-date entry, 10% of healthy school children have a palpable spleen tip. This is presumably U.S. children. Many articles contain the maddeningly nebulous statement that hepatosplenomegaly is very common in the tropics. I have been unable to come up with a reliable figure for the prevalence of childhood splenomegaly in sub-Saharan Africa, and would appreciate Dr. Griffin's estimate for overall childhood splenomegaly in Buduba. Is that how you pronounce it? Bududa? Bududa. There are many medical and non-medical factors in this case that greatly raise the likelihood of malaria. First, Uganda has one of the highest incidences of malaria in the world, with eastern Uganda being described as a malaria holo-endemic region, and that's referenced. Additionally, this is a rainy season with transmission peaks. Children are disproportionately affected. She is not using mosquito netting and has typical malaria symptoms of fever, headache, and splenomegaly. The malaria smear was negative, but Stauffer, 2009, reports that the standard Giemsa thick smear sensitivity for malaria is approximately 85%, certainly enough room for a false negative result. The sensitivity of thick smears is dependent upon level of parasitemia and the experience of the microscopist, with all due respect to WHO directives advising treatment only in proven cases in low prevalence areas. If it walks like a duck, quacks like a duck, swims like a duck, but the duck test is negative, by the way, the duck can kill you, I aver it is a duck. Smears, of course, should be repeated multiple times and supplemented by rapid diagnostic testing if available. It must be recommended that presumptive diagnosis of malaria, i.e. in the absence of a positive smear, even in sub-Saharan Africa, has an accuracy of only around 50%. Though splenomegaly is a symptom of disease, the general opinion holds that enlarged organs are bad. There is some speculative evidence that an enlarged spleen volume may be protective against severe malarial disease and might be a marker for semi-immune status, though there is conflicting data regarding such hypotheses. Other parasitic infections endemic to Uganda that may cause splenomegaly. 1, visceral leishmaniasis. Though the disease occurs in Uganda, its incidence is much lower than malaria. OKI lists 408 visceral cases in 2003. The WHO leishmaniasis country profile of Uganda lists 140 new cases of visceral leishmaniasis in 2015. Compare them to the 2018 WHO estimate of 11.6 million annual cases of healthy facility-reported malaria in Uganda. Our patient's acute and progressive presentation also argues against visceral leishmaniasis as the diagnosis. 2, schistosomiasis. This disease is much more common in Uganda than VL. Exhum's 2019 prevalence study in Uganda notes that S. mansoni is the predominant species in Uganda, with a national prevalence of 25%, with peak prevalence of 36% in the 2 to 4-year-old age group. Exum estimates that as many as 10 million Ugandans may be infected with S. mansoni. Again, our patient's acute presentation with rapid worsening is not typical for schistosome infection, where a subacute or chronic course would be expected. As always, co-infections must be considered, such as acute malaria infection occurring in a visceral leishmaniasis or schistosomiasis patient. Bin Mohana, in 2015, Saudi Medical Journal reports concurrent malaria, leishmaniasis, and schistosomiasis in an 8-year-old Yemeni boy. A laundry list of non-parasitic splenomegaly-associated conditions can be found in the endnotes. This child should receive the WHO-recommended artemisinin-based combination therapy of presumed uncomplicated malaria caused by P. falciparum. Efforts at definitive diagnosis of malaria should continue and supplemented by tests of other agents as the situation dictates. All other supportive measures should be implemented. Use of mosquito nets and other vector avoidance efforts should be emphasized. Thanks for TWiP-induced reveries. And then there's a bunch of endnotes.
Wow. There's triple infection, malaria, leishmaniasis, and schistosomiasis. Does that happen?
I'd throw ascaris and trichuris in there also just for good luck because obviously, it happens a lot, Vince.
What's the most concurrent infections you've seen, Daniel?
So, the interesting thing about concurrent, so as Dickson sort of brought up, the majority of people have some degree of ascaris infection. It's quite a question of how much, right? Mm-hmm. But a solid chunk will have ascaris. Hookworm, another percent will have. Right. So now we're saying, let's say a quarter of the people probably have at least those two co-infections. Yep. And then the malaria incidence is quite high. So those people are, going to get hit with that third.
Right.
So it's pretty often that they have that, and then they bring them in because they've got scabies, right? So,
and then there's giardia, and come on. Yeah. The most our laboratory ever reported on when I was a technician here was 6.
Wow.
And that was a family from Uganda that had escaped from Idi Amin.
I think that's almost the rule that, there's this Occam's razor idea, and Occam was really like a theological philosopher. He was not a doctor. And, it's like, try to find one thing that ties it all together. But it's really these people have multiple issues. Yeah. And you might say, what's the acute issue right now? Right. But, there's multiple things usually going on that you're trying to sort out.
Here.
So I encourage the listeners to look at the endnotes because they're full of great things, and in particular the terminal curiosity.
Oh, that's right.
Which is about nodding syndrome. He said, in the course of reading about this case, I stumbled upon the mysterious, to me, entity nodding syndrome. It's a pediatric seizure disorder.
Right.
Various postulated causes still evades understanding. Quite interesting.
Indeed.
Actually, one of the leading nodding syndrome researchers actually right there at Columbia.
Really?
And nodding syndrome tends to occur in areas, Dickson, you want to jump in, where onchocerciasis exists. And there's some thought that there might be some kind of unappreciated connection between the two.
Nah, I'm good, Daniel. Take it.
You're sneezing there in the background.
No, that was Vincent.
Yeah. Vincent. Oh my gosh. Good.
How is that one?
I'm glad I am at least 1 meter plus away.
It's just tickling noses.
My guess is that he'll edit that out.
Yeah, I will.
I actually thought that was good. But anyway, so Christopher writes, good morning, professors. It is a gloomy 38F here at Stony Brook, Long Island today. For this month's parasite case, I believe there are 2 possibilities that could be infecting the patient. The first possibility is that the patient has a malaria infection and the blood smear gave a false negative result, as many of the symptoms you described are characteristic of malaria. The second possibility is that this girl is suffering from schistosomiasis, as this parasite is very common in Uganda and can cause enlarged spleen and fevers. Additionally, because both of these parasites are extremely prevalent in this region, the patient could also be co-infected by these parasites. In addition to my guess, I thought I would share a paper I thought was a good read and that I thought you would all enjoy as well, PDF attached here. The paper is called The Meaning of Death, Evolution and Ecology of Apoptosis in Protozoan Parasites. The paper discusses the evolutionary processes that would lead to a single-cell protozoan to undergo programmed cell death or parasite suicide. I found it to be an interesting read as I viewed protozoan parasites as selfish cells, only interested in making sure they survive and proliferate, so the idea that they would have programmed cell death conflicted with this thought. Lastly, I thought this Read It post the other day would interest all of you, and particularly Vincent. He gives us a Read It link here about people dying of the flu. Summary of what the link says. In the U.S., more people died from the flu in 2018 than from opioids during the worst year of the opioid epidemic, 2017. Go get your flu shot, with sources from the CDC supporting it. Granted, the people killed by opiates and by flu are a very different demographic, and there are many sublethal impacts of opiate addiction. But I thought it was interesting that something that kills as many people as the very serious opiate epidemic is taken casually. Once again, thanks for the podcast. Warm regards, Chris.
I don't know. I would guess that I would argue that most people take flu casually because they don't get vaccinated.
I think that's what he meant to say.
Oh, okay. Thank you, Dickson. Leah writes, Dear Twipsters, hi. After quite a delay, I'm finally writing in with another guest. Despite the negative blood smear, given the headache, fever, and splenomegaly, I still think we're looking at a case of malaria. According to CDC, while a negative blood smear makes the diagnosis of malaria unlikely, non-immune individuals, which this young girl in good living conditions could definitely be, can be symptomatic at very low levels of parasitemia, making blood smears challenging. I'm assuming that when the patient came back on Wednesday, another blood smear was done, which may have been positive, particularly given the relatively rapid onset of splenomegaly observed. P. vivax is the most likely culprit. Fever spike after 2 days also supports P. vivax as it exhibits tertian fever. If I'm right, I would love to be considered for the hard copy of Parasitic Diseases. Best wishes, Leah, a PhD candidate in immunology at University of Calgary. And guess what, Leah? Even if you're wrong, we'll consider you for a hard copy.
Yes, we will. Yes, we will. Yes, we will. Benjamin writes, to the TWiP triad, I believe the Ugandan child is suffering from malaria, most likely caused by Plasmodium falciparum, in spite of her initial negative blood smear. The tertian fever likely rules out P. malariae, although I'm not sure if fever timing is still used frequently for species-level malaria diagnosis. The WHO Ugandan country report suggests that P. falciparum is the only malarial parasite of significance in Uganda. However, some recent studies have suggested that a reasonable proportion of people in Uganda have been infected by P. vivax. Given the much higher prevalence of P. falciparum, along with the headaches suggestive of neurologic involvement, I think this child was indeed infected with P. falciparum. But at the time of her initial blood smear, her parasitemia was too low to be detected by microscopy. Blood smear negativity is not uncommon, as symptomatic patients sometimes present with very low parasitemias. Treatment in Uganda would be with artemisinin / lumefantrine. It is currently a red-hot 43 degrees C in Adelaide, South Australia, but thankfully there is some rain on the horizon. Thanks for all the fantastic work. Regards, Ben.
Wow.
That's very hot.
That is really hot.
That's as hot as it gets.
Daniel.
So this is from the Western U Global Health Track students, Dana, Stephen, and Chris. Hello, TWiP professors. We believe the most likely diagnosis to be visceral leishmaniasis, also known as Kala-Azar, due to her initial presentation of nonspecific symptoms, and then later high fever and splenomegaly. Additionally, the lack of the mosquito netting could have been the vector. The sandfly, an opportunity to transmit the parasite to her. Treatment would be sodium stibogluconate or amphotericin B. Given her splenomegaly, differential diagnosis would include toxoplasmosis, visceral larva migrans, and schistosomiasis. Sincerely, Western U Global Health Track students.
Alida writes, hello, professors. I hope I am not too VL, very late, to Kala and Hazard. My guess that this may be Kala-Azar VL or visceral leishmaniasis caused by L. Donovani. Sincerely, a VL, very loyal fan. This is great.
It is. It is. No, take the next one because that was a short one.
Peter writes, the case reports 6-year-old girl with headache, fever, muscle aches, myalgia, malaria, negative. Case location and symptoms resemble a case of Katayama fever or acute schistosomiasis. Enlarged spleen, fever, feeling poorly, muscle aches are all according to PD7. exposure via contact with cercariae of schistosoma parasites in bodies of fresh water. Cercariae penetrate the skin, usually through a hair follicle, and acute disease follows 4 to 8 weeks later. According to Sam Lowenberg from the NGO Schistosomiasis Control Initiative, prevalence in Uganda ranges 2 to 92% depending on health district, and 4 million out of 36 million people are infected.
Wow.
National Coordinator for NDTs in Uganda links the prevalence to poor sanitation, as contaminated feces and urine in turn contaminate water. Once again, public health involves much more than doctors and nurses. Since acute schisto is an immune hypersensitivity reaction, treatment should be started with corticosteroids. Antihelminthic therapy with praziquantel can then take place some 6 weeks after resolution of acute symptoms, allowing the short-term immune reaction to subside and the worms to mature from their larval stage, against which praziquantel is not effective. Treatment should be repeated 4 to 6 weeks after the first treatment. Peter, writing from a sunny Cape Town, where I am about to listen to TWiP 585 after a visit to the dentist, and can thus far report that I am on one of only 2 continents that have yet to have a confirmed case of the new coronavirus. I don't know if that will still be true by the time you read this email. It is correct still. It's still correct, right?
How about that?
They don't have a case yet in Africa, correct?
I don't think so.
You don't think so? Let me just check, because we like to talk from facts here.
We do. We don't have to guess. We can look it up.
I'm going to look at a world map, which is put out by Johns Hopkins.
Right.
And I'm going to scroll out. Well, first of all, I can look by country simply on the list,
could.
because there aren't that many countries involved. And Africa is not a country, so it didn't show up.
That's right. See, we're smart enough to know that also.
But there's no dot in South America. There's no dot in Africa, but there is a dot off the coast of Africa. And what do you think that might be?
Madagascar?
No, the west coast, not Madagascar.
The Canary Islands.
Les Palmes de Gran Canaria. Yeah. Canaries had one. Must have been a tourist. For someone coming back from China.
Indeed.
Right. Dickson, you're next.
Yes. Celia writes.
Cilia, like in ciliated.
No, I would call it Celia.
No, cilia.
Okay, Celia. Celia writes, Dear TWiP, greetings from Florida. I've just recently stumbled upon your podcast, so I hope I am not too late with this response for case 179. I'm a fourth-year medical student, and I've been on the interview trail for internal medicine residency programs over the last few months. Your podcast has kept me entertained and intrigued during my long drives and travels, so thank you all. After doing some research, I believe that the diagnosis may be hyperactive malarial splenomegaly, also known as tropical splenomegaly syndrome. From what I gather, it results from overstimulation of the immune system in response to repetitive or chronic malarial infections. It would account for her fever, abdominal pain, splenomegaly, and a negative blood smear. Laboratory testing may show elevated IgM and antimalarial antibody. However, these patients also typically have hepatomegaly and portal hypertension. And on physical exam, no hepatomegaly was noted. Or perhaps it is malaria, although a negative peripheral smear is not as likely, but possible. Thank you all again for this podcast. I'm looking forward to the diagnosis in the next case. Warmest regards, Cilia.
Are you motocilia?
Oof. Are you multiple ciliated?
Okay. Dear TWiP professors, hello again from the Parasitology Club at the University of Central Lancashire in the beautiful northwest of England. Our multinational group of students has been bitten by the parasitology bug and have come up with a list of candidate organisms for this sick 6-year-old and firm favorite amongst them. On our list of candidates were Schistosoma mansoni. It is a waterborne trematode fluke, and symptoms of infection can include fever, belly pain, cough, malaise, headache, rash, body aches, and fibrosis in spleen and liver. Capillaria hepatica, a nematode parasite with a natural host in wild rodents, geographically possible in the African region, but a rare cause of infection in humans. However, we believe this could be a case of malaria. Typical symptoms of malaria are cold, fever, hyperthermia, headache, nausea and vomiting, lack of appetite, muscular pain, convulsion, mostly in children, anemia, followed by splenomegaly at later stages, coma. Members of our group are from Nigeria, Mozambique, and Suriname, and have personal experience of malaria, and this provides the rest of the group with a fantastic insight into daily life in an endemic region. Diagnosis can be quickly confirmed by examining thick and thin blood films stained with Romanowski stain. This may also be used in combination with other stains such as Reich-Gimsa and May-Grunwald. A false negative smear on the blood film is not uncommon, so the child may have been asked to return for a repeat smear. Malaria rapid diagnostic tests are useful in diagnosing malaria by identifying the presence of different species of malarial parasites. They are used as an alternative to microscopy due to their rapid, handy, and inexpensive characteristics. The test normally involves usage of a cassette containing a nitrocellulose strip. Typically, a drop of blood is obtained via a finger prick, which is introduced to the sample port along with a buffer solution to carry the reagents along the strip. After a few minutes incubation, the results are visible in the form of 2 red bands in the case of positive infection, or 1 red band in the case of a negative infection. RDTs reduce the pressure on local laboratories in that people can carry out the test in the luxury of their homes. Minimal training is required as the kits come with step-by-step instructions. In addition, this is advantageous in rural areas where there are minimal resources for quick and proper medical diagnosis. However, RDTs do not tell which malaria parasite one has been infected with, which may lead to inaccurate self-medication and even resistance on the long run. I'm going to actually say that is true with some RDTs, but not with all. Some are species specific. It is recommended that a positive result on the RDT can be confirmed in a diagnostic laboratory. And we get included one of the RDT cassettes, one of the lateral flow assays. We would be proud to receive a signed copy of PD7 and our collective fingers crossed that we will be lucky enough to be randomly selected from the TWiP writing in to solve this tricky case. Thank you again for your wonderfully informative podcast that stimulate the discussions in our group. With the warmest regards from the cold north of England. And then this is from David, Saleha, Dennis, Abba, Aneki, Katie, Charlotte, Hunea, Mandy, Jessica, and Joe.
Wonderful.
Outstanding.
The ID team at Karolinska writes, Dear professors, thanks so much for your interesting and entertaining podcast. We are a group of infectious diseases, trainees, nurses, and assistant nurses working at Karolinska University Hospital in Stockholm, Sweden. We have used your great case presentation in our weekly teaching session as a means to learn more. Just as an aside, I was in Stockholm in August of last year, and I stayed right across from the Karolinska Hospital at the, what was the name of that hotel? Caroline Hotel, something like that. It's owned by the university. It's brand new. They have clinical stuff in, so it was really nice. I was near you people.
Oh, nice.
In the latest episode 179, you presented a case of a 6-year-old girl in Uganda with a fever, massive splenomegaly. Our differential are chronic schistosomiasis, visceral leishmaniasis, hyperreactive malarial splenomegaly, and echinococcus. But we also thought about non-parasitic reasons such as lymphoma, ALL, AML, or thalassemia major. Differentiating the non-parasitic diagnoses is likely to be difficult since the necessary blood tests are unlikely to be available in an outpatient clinic in rural Uganda. A low hemoglobin would also be found in many of the differentials. We assumed the patient didn't have any other symptoms like lymphadenopathy or purpuritic rash, which may favor a hematological diagnosis. We felt that thalassemia major is unlikely since the patient has survived until 6 years. Thalassemia minor would be possible with the potential for major having killed other siblings. Now for the diagnosis. Splenic echinococcus cyst would be unlikely since it's not the most common place for a cyst. The patient is young, no mention of sheep or dogs, or diet mostly vegetarian. To fit the clinical picture with fever, such a cyst would then have to have a secondary bacterial infection. Chronic schistosomiasis is valid since household water is collected from a nearby stream. The girl could be collecting water for the family and therefore be repeatedly exposed, but we thought she might be a bit too young for such a massive spleen. Splenomegaly would also require an enlarged and fibrotic liver, something not found on exam. Chronic schisto does not lead to fever. Visceral leishmaniasis is also a valid differential, which is rather common in this region, although we were a bit unsure about eastern Uganda specifically. Hepatomegaly is usually also seen, with this diagnosis, as well as weight loss and general lymphadenopathy, which was not mentioned. As visceral lice could be quite asymptomatic in the initial phase, this could be the early sign for the disease developing. Our top differential was hyperreactive malarial splenomegaly, caused by repeated malarial infections. These patients also have negative microscopy for malaria, which was true for this girl. Her age fits. It also was mentioned that it was currently the rainy season, no bed nets, higher risk of transmission. To explain fever and malaise, she could now have acute malaria with developing symptoms and undetectably low parasite count on Monday. Another option is a concomitant bacterial infection such as typhoid or non-typhoidal salmonella, common with malaria. Thalassemia minor could be consistent with low parasite malarial infection since it is protective from severe malaria. Following tests we need new smear microscopy for malaria and preferably rapid antigen test for Leishmania RK39 available, or smear of splenic aspirate, stool exam for ovum parasites to detect eggs, possibly schisto, and hemoglobin. Treatment: malaria positive, treat for acute malaria. Consider treating for acute bacterial infections, salmonella, non-typhoidal, ciproflox, or ceftriaxone. Treatment of other diseases depending on test results. If we win the book, we will use it in our outpatient daycare clinic where we see a lot of patients with travel history from tropical countries. Greetings from a snowless, wintry Stockholm where it is now 2 degrees C. ID trainee team at Karolinska. Karolinska. And that does it for our guesses. 15 in all today. Actually, more, but those are the ones that are eligible for a draw.
Exactly.
Okay.
So it's time to do that.
Dickson, what do you think?
What do I think? Well, I think it's malaria. For sure, I think it's malaria, even though it's negative on the blood smear. And I was trained as a parasitologist to go on hyper alert when I heard that it elicits a big spleen in young children. All right. Now, the reason why is because there was a disease back in the day when I was training, when I was in school, called big spleen disease. And it was a disease specific to Plasmodium malariae. And that hasn't been mentioned much here, except to say that it's not very prevalent in Uganda, but Lord knows what the true prevalence of any disease is in Africa. So big spleen disease was diagnosed simply by trying to feel for the spleen. They didn't even have to do a smear. If the spleen was enlarged, they immediately assumed malaria until proven otherwise. Of course, hepatosplenomegaly would have ruled in leishmaniasis. So my guess, without a further diagnosis, and of course I would wait for the blood smear to show the differential, would be a big spleen disease due to Plasmodium. And then I would sort of secretly hope that it's Plasmodium malariae, a rare but findable result, and major cause of big spleen disease in Africa. That's my secret hope. Send me a book if I'm right, would you? Hey, wait a minute. I've got some waiting for me at home.
Got a whole box right
I
here.
can sign a couple even.
You should sign.
What about you, Vincent? What are your thoughts?
So I had two. I thought either visceral leishmaniasis or malaria. But
okay.
I missed the part about coming back in 2 days, though. That was a great clue that one of our earlier guessers picked up. And
Indeed.
If I had picked that up, I would have said then probably malaria.
Yeah.
Right. It's very, very clever.
But
a number of people
has hepatosplenomegaly. She has no.
Yeah, I got that. Yeah. That's very good. You're a parasitologist. I'm not.
Well, yeah.
I feel like Vincent is a card-carrying parasitologist at this point.
Come on.
There are probably few people on the planet, Vincent, with your level of parasite knowledge.
You're
at this
quite
stage.
right. You're
having absorbed it from TWiP.
There you go.
180 episodes. I've come 180 degrees.
You have.
That's a lot of hours.
It is.
Talking about parasites.
It is.
Daniel, you had her come back in 2 days. What did you do?
So the emails were great this time. I mean, they're always great, but there were a lot of really good things that people brought up here. So there's always a bunch of different ways to approach a problem. So one of the ways I always say is, you want your geographical history. So where are we? We're in a certain area of Uganda. So it's not like just Uganda, but we're in the Bududa district. So one of the things you approach this first is say, well, what is common in the Bududa district? So people brought up, for instance, the visceral leishmaniasis. And the nice thing I'll say about our podcast, you can Google, you can look stuff up. And so, if you're worried about visceral leishmaniasis, you could ask, well, is that, what part of Uganda has that? There's only 100, 200 cases found a year. And most of the cases are north of Bududa, up in the Karamoja region. And so that would be north of us. You're not going to see a lot when you get down into Bududa. So we've got epidemiology helping us a little there. The next epidemiology might be schistosomiasis. There's lots of schistosomiasis in Uganda. And so, we're describing a young child who's right there in the Bududa region. If you're south on the shores of Lake Victoria, you're going to be right in the heart of schistosomiasis country. And if you go north a little, where there are some more lakes and other areas, you're going to be into a higher schistosomiasis area. So I think the differential is, I think it's great what people brought up. They said, we're worried about malaria, we're worried about visceral leishmaniasis, we're worried about schistosomiasis, particularly acute schistosomiasis, Katayama fever. But again, I'll say, okay, so the epidemiology is pushing much towards malaria. We're not really in a high prevalence area for visceral leishmaniasis or for schistosomiasis, unless maybe the story was, I was just up in the district above, and it was a few weeks before when we were swimming in the shores of this lake. So less likely, from sort of our history and geography. And the other was that 2-day thing. And so the issue is that one smear for malaria, particularly early on in the symptoms, is really not enough to rule out malaria. So the first thing we did was, and actually this was sort of when you come back in 2 days, go get a malaria test and then come back and talk to us. And what do you guys think the malaria test showed?
Plasmodium.
It actually, yes, it showed parasitemia. This individual, and this was an interesting thing. The people in the region sort of created in their head this idea that it was, it's the early hepatic phase, but actually you really don't get fevers until there is starting to be some parasitemia.
Right.
But the parasitemia might be below the detection of the microscopy at that point.
But you probably wouldn't see any gametocytes at that stage either, because it's early on in the infection. So you probably would just see rings if it's P. falciparum.
Exactly. It actually takes quite a while, right? As we know, before you start getting the gametocytes, which is actually the form that the mosquitoes can pick up and then transmit.
Correct. So what did you see then?
So lots of ring forms.
Lots of ring forms. Any multiply infected red cells?
In this case, there were some, yeah.
Okay.
So, and then people brought up the issue of the RDT versus the smear. In this case, we went ahead and just did our smear and saw the parasitemia. And another, I guess we should bring up this issue of the spleen. What's up with the spleen versus the liver? Okay, so we have our, in a sense, confirmed diagnosis. But what was I thinking on exam? So there's two issues with splenomegaly. So there can be a syndrome. Let's say we had gone ahead and done the smear again, and this person had persistently, we checked them then, we checked them again in a week, they had chronic splenomegaly, but they always had negative blood smears. And we do see this in Africa. Yeah. And this is this splenomegaly syndrome that's been described. These people, sometimes we see this in immigrants, actually, that or refugees that have left a malaria endemic area. If you do a PCR, they tend to have a low level. It's usually Plasmodium malariae, and it's a hyperimmune response. They have a robust immune response to a really limited amount of parasites. In this case, I think this was just acute splenomegaly in response to an acute malaria infection.
And you think it was falciparum?
In this area, you go into it with an odds ratio of greater than 90%.
Sure. And
then we do smears, so you can actually speciate on the smears. What about the age? What about the age of 6?
I was going to ask about that too.
Yeah, so that and I think one of our emailers brought this up. If you look at mortality for malaria in Africa, it's not in the under 5 and it's not in the over 20. It's actually in this sort of 5 to 15 year age period, and actually maybe clustered at the 5, 6, 7. It's before they've been exposed to malaria to produce the immunity that develops.
Right. And maternal antibodies are gone,
and
right?
after the maternal antibodies have gone. So this is this big vulnerable period of time.
Right.
And what did we do with the girl?
So we treated her, and it's really easy. Basically, you weigh the girl, and then there's different, you're going to get, so it's going to be the coartem, which is the artemeter lumefantrine. And it's basically going to be, if you're in this weight, you get, 1 tab per dose. If you're this, you get 2. By the time you get to adults, well, greater than 35 kilograms, it's 4 tabs as initial dose, and then 4 tabs as your follow-up doses.
Right.
So yeah, and now, in a girl who's sick like this, sometimes depending on how sick they are, we'll even give the first dose intravenously.
Oh my!
And in this case, this girl, the first dose was given intravenously.
Another thing to point out is that this is the rainy season, so the likelihood that this little kid was out playing and got into the river or got into a lake is pretty low because people usually stay indoors when it rains a lot. So
after this course of drug treatment, will she be parasite free?
That's interesting. She's living in this area. She's going to continue to get bitten, so she'll get better. And, and over time, people in an area like this will keep being reinfected, but that premonition is what we call it, will develop. And so she'll stop getting sick. But you're constantly getting exposed. So, a lot of the people that go to volunteer in these areas will take medication while they're there, and actually for a period of time afterwards, to protect themselves from getting sick. That becomes sort of financially and otherwise untenable if you're going to be living in an area like this. So it's really the premonition that develops, and you just need to be really careful during these vulnerable periods of life that people don't get sick. And
so Daniel,
die.
as she grows up, and let's say she is a bright student and was accepted into a university, and she goes to Kampala or some other place, and she stays there for 3 or 4 years, and then comes back home. How long does that premonition or malaria last to protect her from reinfection?
Yeah, so that's a problem, actually. So, you think it probably lasts more than a year, but by 2 years, no. And
right.
So, we often say that, you may be, so this is, I think I've mentioned this on prior, like we see people come from West Africa, particularly to study in the U.S., some people from Uganda, et cetera.
Yes, indeed.
And they've been here in the U.S. They say, I'm heading back home. And they think of it, they're heading back home, no reason to worry. And I say, you know what? In your heart, you're still African.
Right.
But in your blood, no, you're not.
Right.
So for them, it can be risky, and it's this group, we call them the VFRs, visiting friends and relatives, people going back to their home who they don't want to insult people, they don't want to hang up the bed nets, they don't want to be taking medicine every day. The perceived risk isn't there. And those are the people outside of that 5 to 15 when we see mortality concerns. People are actually getting particularly sick.
Indeed.
Now, you said you gave her a combination artemisinin with something else, right?
Yes, the coartem, and that's important in the way we treat malaria. Is that there's usually an agent with a really rapid onset of action, so that's your artemether. But you always want that second medication, and so it might be doxycycline, it might be clindamycin. Back when we were doing quinine-based or quinine-based therapies with the artemeter, you need a second long-acting drug. Otherwise, you're going to get this recrudescence. I've got never quite clear, and then the parasites come right back.
Right.
So that's critical.
There's no worry about resistance in this area?
So in this area, we don't have significant resistance to, as Dickson, to the new drugs, I will say. But you're not going to be able to use quinine in this area. There are very limited areas of the world where you can use the original quinine and quinidine type drugs. But the areas where we're having the biggest issue with resistance was that area where I was in a few years ago, the Cambodia, Burma, Thailand region, where they actually are rotating back and forth with different drugs to sort of keep away from the resistance.
All right. Great case.
Yeah, that was great, all the groups of students.
Yeah, nice stuff. Nice stuff.
All right, let's pick a winner. We had 15 entries.
You want a drum roll?
Number three.
Number 3.
We always get low numbers here. I don't know.
Do we really?
What's with this random number generator?
Really?
This is
Maybe
Mandy.
it's a bot.
Mandy from Mandy from Nashville. Mandy from Nashville. Okay, Mandy.
Great.
This is the one who nominated Dickson for.
That's right.
The coveted book report.
This was not a rigged election, by the way.
No, it's a random.
Selected.
I did it randomly, and it's number 3.
Exactly.
15. So, Mandy, send your address to TWiP at microbe.tv, and at some point in the next decade, I'll get you a book. I'm sorry it takes long. I have a lot of stuff going on, but one of these days I'll get to it. Now, speaking of malaria,
yes,
and speaking of artemisinins,
indeed, or resistance.
I shouldn't laugh, but
no.
Daniel selected a paper.
Indeed, he did,
and it's very interesting. It's called a Kelch-13 defined endocytosis pathway mediates artemisinin resistance in malaria parasites. This was published in Science, and the authors are from, the Bernhard Nocht Institute for Tropical Medicine in Hamburg.
Great.
Department of Molecular Biology at Radboud University in the Netherlands.
Right.
And so we have the first author being Jacob Birnbaum. The last author is Tobias Spielman. And here they want to know how these mutations to artemisinin work. And the key to begin the study, the parasite, the malaria, this is Plasmodium
falciparum.
Or
falciparum.
I notice we all have it's okay. Both are right. It's all good.
The genome harbors, of course, the mutations that lead to resistance. And what they tell us early on is that these are in a protein coding gene, a gene coding for a protein called Kelch, Kelch 13, which was new to me.
Me too.
Never, I never heard of Kelch. Not even 1 through 12. Never heard of. So Kelch, and they want to know what is going on. How does this mediate resistance? And so they use a combination of very interesting co-interaction experiments.
Right.
The first thing they do is, they mention that this Kelch 13, if you label it with a green marker, it in the malaria, it's near the parasite's food vacuole.
Indeed.
Is that run by Whole Foods?
It can be, yes.
I think Amazon is buying it. Yes.
Right.
Lysosome-like compartment where parasites digest endocytosed host cell cytosol, predominantly hemoglobin. So these parasites are within the red blood cell, right?
Yes.
And they're endocytosing.
They are.
Dickson, you're not going to jump in and say, well, they're not really in the red blood cells. They're in the parasitoporous vacuole.
I will let you say that.
All
right. Well, they're being carried along within the red blood cell.
Yeah.
In some
Anatomically speaking, they're not, but when you look at them, you can't see that they're not.
Yeah. So they're endocytosing cytosol and they're digesting it in their food vacuole.
Right.
And so Kelch 13 is near it. But it's in an unknown compartment that no one knows. No one has seen this structure before.
Exactly.
So they look for proteins that are interacting with Kelch 13. There's a couple of very interesting methods. I don't think we need to go into them, but they pick up a number of cell proteins, including ones that are known to be suspected in resistance to artemisinins. Isn't that interesting that they're associating with Kelch? And another protein that's interacting with Kelch 13 is called EPS 15. Now, I understand that these mean nothing to most of us, but they are. EPS 15 is known to be involved in endocytosis.
Indeed.
Mm-hmm.
Which is what's going on here, right? To take up the red blood cell components. So they're thinking, okay, this must be involved in uptake. But what's weird about this compartment that has Kelch 13 is it doesn't have clathrin. Clathrin is a protein that coats endosomes typically when they come in from the cell surface, but they can be independent of clathrin.
Right.
And this apparently is a clathrin-independent endocytosis pathway. And they have a number of different proteins that are involved. So Kelch 13 is part of a compartment that is part of the endocytic pathway, but it doesn't have clathrin. And somehow this is involved in artemisinin resistance. So then they can start to disrupt these genes and ask what's going on. And they can inactivate a few of them, and this reduces the transport of hemoglobin to the food vacuole.
Right, and this is the
reduces, but not eliminates.
No, that's right. But it slows down their metabolism, but it still prevents them from getting exposed to the drug, though, right? So it's like a trade-off.
I think that's the idea here, right?
It's really an activation, right? So there's what we find as we go forward, that the ARTs, that's our artemisinin-based drugs, are actually activated by the degradation products of hemoglobin. So if you somehow interfere with the sort of eating process, so you diminish the hemoglobin endocytosis, you diminish the ART activation, and then the parasites are resistant because the drug isn't being activated.
Yeah, but you were worried that they need the hemoglobin, right?
They do. That's their food.
So how do we reconcile this apparent paradox?
Exactly. Or a pair of ducks.
Daniel, do you understand Dickson's concern?
No, it's interesting because you'd think there has to be a fitness cost.
Yes,
right?
Yes.
So.
Right. So these organisms must grow slower. Is that correct, Daniel?
Actually, that's an interesting issue. I think I think that's one of the good things is there is a fitness cost to artemisinin resistance.
So then does that give your immune system time to catch up?
To some degree, yes. And so that, I don't know how much they show here, but when you look at it, there is a slowed ring formation in Catch3, mutation carrying plasmodial species. Mm-hmm. Not enough to, because this is interesting. When you usually treat someone with, we'll say you're treating someone who has a Plasmodium falciparum, and this has no artemisinin resistance at all, and you go ahead and treat them, and let's say they've got 10% parasitemia, which, a sick person. By the next morning, you're going to see 1% or less, a very quick response. Right. When someone starts to develop artemisinin resistance, what you're seeing the next morning is not 1%. Maybe you're seeing 2% still. So they're still getting better. It's just that you've decreased the efficacy of your drug.
Mm-hmm.
Okay.
So speaking of drug, then they take these gene knockouts, which we have shown inhibits endocytosis, and they ask, are they resistant to artemisinin? And a good number of them, an activation of more than half of the Kelch13 compartment proteins, as well as Kelch13, reduces the responsiveness to artemisinin. So multiple ways you can get resistance, presumably. Mm-hmm. They even take a change that is found in a patient and put it into their system. It's in one of these other proteins, interacting proteins called UBP1, and that change makes their model system resistant to artemisinin,
proving that it's the endocytosis effect of preventing.
So it seems to be they're inhibiting endocytosis, as Daniel said. The artemisinin has to be activated, right, by the hemoglobin. But they also show that there is reduced levels of Kelch13 in resistant parasites, and that's they speculate that is why endocytosis, at least in cells with mutations in Kelch13, is inhibited. Okay.
Mm-hmm.
But so the implication is a certain level of Kelch13 is needed for endocytosis. So if you get a mutation that drops the level, that will inhibit. So that's one mechanism of artemisinin resistance.
Yeah, and there's several Kelch13 mutations with, at least if you look through the literature, different apparent fitness costs. So that is the malaria parasite is under a certain pressure, right? The fitness cost pressure, but also on another, this drug exposure. So there's a balance. You don't want to completely lose your ability to eat, but it is making it vulnerable to the ART activation.
Yeah.
So instead of gulping, it sips.
So here's their bottom line. Kelch13 and the other compartment proteins control endocytosis levels, thereby influencing the amount of hemoglobin available for degradation and hence the concentration of active drug.
That's amazing.
It's quite interesting. Yeah,
it is. I remember when I was in at Rockefeller, I saw some of the first pictures of the electron microscopy of malaria parasites, and the very obvious first thing they saw was the way that the red cell hemoglobin got into the parasite. Because the food vacuoles would just bud off from this endocytic event and form little clusters inside the cytoplasm of the parasite. But the opening that allowed the original hemoglobin to come in was huge. It looked like the Lincoln Tunnel rather than some penocytic vesicle. It was big. So it's when I saw this paper, I thought, how could you block something that large just with a mutation? And it would be interesting to see what the electron microscopy. I know there's a picture or two in this article to show the gateway, so to speak.
Yeah.
But it doesn't physically explain how it works. At least I didn't see
the localization, but they don't really give you a mechanical.
Yeah, exactly. I did not see actually how this thing works.
Yeah, it's interesting. I mean, the Kelch. So Kelch is this motif, right, where you've got these. It's almost like 4 blades, and that is involved in the way
it a
this
propeller protein, right?
Yeah. So there is some way of thinking of it as sort of mechanical.
Is it a molecular motor? Is it a molecular motor?
They call it a beta propeller domain.
I don't think it's a motor. That's just a protein domain. Many proteins have propeller, like the influenza neuraminidase has a propeller domain, but it's not a motor.
Got it.
So one of the things they say you can do here is that now you can do population studies and see the changes in these other proteins besides Kelch 13 that they've identified that give rise to resistance. So you could look in different areas and say, can we use this drug at all, right? Or there's resistance and we shouldn't use it.
Because that's key for the monitoring of resistance, and it's been a challenge. Does what we look for at a genetic level correspond to what we're seeing phenotypically? So it's really important for these studies where you're tracking resistance to know where to look for the mutations.
So Daniel, when you treat a patient, you don't genotype the parasite, right? You just treat them.
So we don't where I practice, but where they're up in areas with growing resistance, like the area I mentioned, the Burma, Cambodia, Thailand area, they're actively tracking. And then there's issues when a new mutation comes up that isn't in part of the genetic tracking panel, and they've got to try to figure out, okay, why is this resistant? Because we didn't pick it up on our PCR screen.
Now, for treatment of AIDS, you do genotype before treating with a drug, right?
We do, actually. Before you treat someone with HIV, it's fairly standard to do a full sequencing of the reverse transcriptase. And also now the integrase, looking for resistance, because you don't want to put someone on less than 3 effective drugs.
Yep.
So
I see. So you tailor the drug depending on what mutations you find in the RT and the integrase. Yeah. That's cool.
Exactly. And the protease too. So, and then if a person has breakthrough, then we sequence to see what are they resistant to, and that helps guide us in our next drug therapy.
Yeah, when I visited the clinical microlab here, and there's a huge machine which he said is devoted to doing that HIV drug sequencing, because there's so many, right? And someone fails drug treatment, you have to find out why, so you have to sequence it again. It's amazing, but it's great.
It really is. I mean, and there were many years developing that database so that now we can take a genotype and know what phenotype that results in. Initially, we used to actually have to do genotype and phenotype as we're trying to determine which genotypes result in which phenotypic resistance. So, yeah, fascinating.
Okay, let's see if Daniel has another case. What do you think, Dickson?
Good. We're going to put the hero on hold.
The hero is on hold. That's wonderful.
No, I am trying to distill down a suggested hero. They sent so much information that I couldn't possibly find the time to read all of it. This is a very interesting person from Mali. We will get to this the next time, I promise.
Okay.
Right. All right. Well, I look forward to that in the future. But here we go. Yes. No, I mean that.
It's all about you.
But now let me go. Okay. So I hope people enjoy this. This is going to be another case in Uganda, but with a little bit of a twist. On arrival in Uganda, I am met by two long-term volunteers, a global health intern and a recent nursing graduate. Mm-hmm. After a little bit of conversation, it becomes apparent that they are both suffering from a problem with watery diarrhea with about a dozen episodes per day. There is some nausea, some abdominal cramping, a loss of appetite, and this has been going on for over a week now, right? So a dozen episodes per day of watery diarrhea for over a week. There's no fever, no blood, and things are not getting better, no improvement in symptoms. Although they've been living for months at a staff guest house for volunteers with no issues, they do report that about 1 week prior to the onset of symptoms, they went on a weekend trip up to an area with waterfalls, sippy falls, and they were served a very nice outdoor meal. Neither individual, we don't know if this is related, neither individual recalls if there were raspberries, basil, snow peas, or mesclun lettuce served. Combining
or anything else for that matter.
And no significant past medical or surgical history for either of these individuals, not allergic to any medications, and family history doesn't add anything. So this is going to be, I'm going to give you a little more of, so I take this in and I think about it, and I recommend an empiric treatment with trimethoprim sulfamethoxzole for 7 days. And after a few days of therapy, both individuals report prompt resolution of the diarrhea. Now, a few days after the resolution of the diarrhea, one of the two individuals is feeling much better and orders a large coffee with mostly milk and promptly has severe cramps that then resolve when I recommend that they avoid dairy products for a while. So what was I thinking, and what do we think this probably was?
What was the treatment again?
So it was trimethoprim sulfamethoxzole. So that would be Bactrim or Septra in a lot of parts of the world. So, Yep.
And they don't know what they ate up in the mountains, right? You said none of these vegetable thingies, but is there anything else?
No, it's a long list of things they didn't eat. What did they eat, by the way?
I gave a list of what they didn't eat.
Did they have meat?
So there was meat, there was salad, there was fruit.
No fish?
There was no fish.
What did they drink?
They drank water and there was juice.
Thank you.
And they're HIV negative?
They're both HIV negative.
These are two volunteers, right?
They're two volunteers, both long-term volunteers there for months.
How old are they?
Both in their 20s.
And they're male?
Both female.
Female
Aha.
Volunteers. Okay.
Fascinating.
Any questions, Dickson?
Too many questions.
Too many questions.
It's not fair to ask the questions that I want to ask.
So they're staying at a staff guest house, and everybody else is okay, right?
Everybody's okay. Yeah.
Nobody else went to the dinner except them, though. Is that right?
Just the two. The two of them were the ones that went off.
Right.
Sorry, Dickson.
No, that's okay.
How long after the eating did they come down with symptoms?
So it was about a week. It was about
1 week.
Yeah.
1 week. Yes. Sorry. Yeah.
About a week after that weekend trip.
Yeah. And in the meantime, they have not cared for any patients with untoward illnesses.
Well, they are working in the clinic, right? So they are exposed to a lot of different things.
Okay. But they're sleeping in a place with screens or whatever, windows and so forth.
So where they sleep, they are in malaria prophylaxis, so that's an important thing. They are sleeping under bed nets.
Right.
Okay. All right. Thank you. Look forward to new guesses from our listeners.
Exactly.
I just want to mention one very nice email from Caitlin, who sent in a guess late for last month's guess, the Ascaris case.
Oh, yeah.
Yes.
And so she did get Ascaris, but she writes, on a lighter note, it's been millennia since I submitted my fan art, so here's a picture of you guys as the Three Musketeers. So a nice little painting of Daniel, Dickson, and me as the Three Musketeers. And Caitlin in Seattle, where we finally got the first snow of this winter on January effing 9th. This place is too warm.
Right. Oh. Well,
it's a pretty picture.
It is. I'm honored to be part of the TWiP trio.
We'll put it in the show notes.
Oh, I like that.
You see that, Dickson? Do you see it, Dickson?
I'm looking.
And Daniel, you can see it, yes? Okay, good. Thank you, Caitlin. Very nice. All right, that's TWiP 180. You can find it on your podcast player, whether it's a phone or a tablet. And if you do listen that way, please subscribe. Get every episode. We know how many people are listening. And if you want to send questions, comments, guesses for the clinical case, TWiP at microbe.tv. If you want to help us out financially, microbe.tv/ wait a minute, what is it? Contribute. Microbe.tv/contribute. As you know, Parasites Without Borders is an organization that was founded by Daniel and Dickson and others to educate about parasites in places where it's needed. And you can support them. You can go to their Facebook page, Parasites Without Borders, and, of course, parasiteswithoutborders.com to figure out various ways that you can do that and contribute and help disseminate knowledge. Is that right, Dickson?
It's the only reason for doing it.
Dickson Despommier.
Oui, monsieur.
Thank you very much. You're at trichinella.org and thelivingriver.com. Thank you very much.
You're welcome.
Daniel Griffin's at Columbia University, Irving Medical College and Parasite Without Borders, parasiteswithoutborders.com. Thank you, Daniel.
Oh, pleasure as always.
I'm Vincent Racaniello. You can find me at virology.ws. I want to thank Ronald Jenkins for his music and ASM for their support. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP is parasitic.